Hello and welcome to the webinar. Today's topic is going to be hybrid modeling with solids and surfaces. So what is hybrid modeling? Well, this is when you basically use solids and surfaces together. Now, why would you want to do this? Well, sometimes you just can't get your model to finish with just solids, and you try and use whatever techniques that you know, and you just can't get it to complete. So you bring in surface tools, and a lot of times these surface tools will they'll create faster results for you, but they'll also allow you to use different techniques to actually get different designs done that you may not have been able to do with solids. Surfaces are great as reference geometry and supporting geometry. In fact, I'm going to use a lot of that here today. But what you want to always keep in mind is to use solids when possible. SolidWorks is a great solid modeler. It does have very, very good surfacing tools, but our end result is typically a solid model so that we can do more things with it downstream. So always try and use solids when possible. So let's go ahead and jump into this. What I'm going to do is show you several different real-world examples of hybrid modeling where I brought in surfaces to help with finishing up my solid design. A lot of these actually came from the user base, the customers that I've worked with over the past many years. Others I've just come across in doing research and training and tech support and everything else that I've done for many years here. So the first one here we want to talk about is manual fillets, and we know SolidWorks is really a great filleting tool, but there are times where we just can't get the fillet that we want to go into the space that we want because we just don't always have material to allow that fillet to exist, or you may end up having kinks and bends and just other areas that won't allow that fillet. So the hole that you see kind of shadowed in right here, we want to turn that hole into a rounded edge. So how do we go about doing that? Well, let's jump into SolidWorks and let's take a look. So here's that finished model, and let's take a look at what do we have at the beginning. So we started out with something like this, and we come in and add our fillet, and 10's not going to work, so let's just add a 3 millimeter radius, and the fillet goes in, except we can see this face right here is just not going to work for us. So how can we get around this? Well, what I would recommend you do is go ahead and put your fillet in so that it gets the base of what you have here, and what we're going to use is this face as a reference. But we need to get rid of all of this area inside of here between these two. I'll get away from that dimension. Between these two edges here and here, we want to clean out all of this and then manually add in what we need. So how do we do that? Well, first thing we want to do is delete this face. Now, how do we go about deleting faces? Well, you can right click on it. If it doesn't come up in your face area, just come down to chevron at the bottom, and you'll see you've got more options here, and there's your delete face. Now, where else can you get delete face from and all of your surfacing tools from? Well, you've got the command manager where you've got your surface tools here, and there's delete face. I'm a huge S key proponent, so I've added my surfacing tools to my S key, and I have delete face there. Or if you just want to use the command search, hit your S key and begin typing delete, and you'll see up at the top here you have delete face. So however you need to get to your surfacing tools, they're all available in many different places. So let's go ahead and jump into delete face, and you'll notice there are 3 options up here: delete, delete and patch, and fill. I'm not going to go through all the options. We just want to remove this face completely and clean up the area. So I've deleted the face. Now, one thing you want to always understand is when you delete a face, you go from a solid body to a surface. Let me roll back once just so you can see this. So here we have our solid body, and as soon as I delete a face, this turns into a surface body. Alright, so you want to be real aware of that, and then you can see we've got a hole in there and it's selecting surface face on the opposite side there. Alright, so we've cleaned out that one face. Now what about this hump right here? We need to get rid of this little hump. How do we do that? Well, we're going to use a plane to trim it out. So let's go create a plane. It does not exist right now. Alright, get to my reference geometry. We're just going to create a plane along this circular edge. Alright, and I have a plane, and I'm going to use that plane to trim along that edge. Now that plane does meet up to these two corners here, so I can feel safe that I'm going to have a good clean cut there. So to clean that out, what we want to do is come down and use what's called trim surface. Now we don't have cuts in surfacing, so we use trim instead. And there's several different ways to trim. You've got a standard and a mutual. I'm not going to go through all the settings, but we're going to use a standard trim. The plane tool is going to be our cutting tool, and then down here just below it we can either keep or remove sections. So I'm just going to tell it to remove this little hump right here that we want to get rid of. Alright, and away it goes. There we go. We can hide our plane now. Alright, and now we've got the opening. Now, what we need to do next is close this out. So this is where I'll introduce one of my favorite surface tools called Boundary Surface. So Boundary Surface, when it first came out, I kind of had to figure out how to use it. The first thing I realized that it was a great replacement for the loft command. So it's kind of how I'm going to use it here. And I actually do, I don't know, more times than not, I end up using it in place of lofts, because what Boundary allows me to do is through this direction 1 and direction 2, I can drop in my profiles in direction 1 and then drop down to direction 2 and use guide curves. Alright, so there are my guide curves. And also, while you're in here, you can turn on different curvature display. So if you want to take a look at the curvature of the face that you're adding, and not only that, but maybe the curvature combs. Let's drop these down so we can actually see what's going on. And these curvature combs, which will show me how the curvature of this thing is going, and to make sure I don't have any inflection points where we have a change in curvature. Alright, so we'll just turn that off for now. The one nice thing that I like about Boundary is that it allows me, with these tooltips, every edge that I select, I can have control independently. Whereas if I had multiple profiles in here, each one I could control independently, whereas lofts, I can only control the front and back end. I can't control any of the intermediate lofts in there. So I'm just going to leave this as is. Drop in the face. Everything looks good, and I'm happy. Now I've got two solid bodies, or I'm sorry, two surface bodies, and now what I need to do is bring these together and do what's called a knit. So as you create multiple surface bodies, what you want to do is knit them together so that they create a single surface body. And not only a single surface body, but as you knit them, you'll also have an option here called Create Solid. If that option shows up, then it has enough surface bodies to create a watertight closed body, and it can then turn them all into a solid, which is our final goal here. So now I've got my final solid, and I've got the fillet added in. Alright, so very straightforward, very simple. I really only needed to create one surface, but then use one or two surface tools to finish it out. Alright, so that's our manual fillet. Alright, and you can, this same technique in removing unneeded faces, cleaning up the area, and then using surface tools to add in surface bodies and then knit them together. That technique you can use over and over and over again in lots of different cases. So let's move on from here, and this is actually one that came from a customer of mine. I was actually teaching a surfacing class a few months ago, and they asked about creating what they called a square spring, and that's the image that you see in the middle here. And I'd actually done that once before with this coil around a frame, and we'll look at both of them. But the square spring, they asked about this, and I said, yeah, absolutely. You could either model the the 3D path that you need in here, because you can't use the helical feature because it's not circular. But there is a really awesome tool that does include one surface that will allow me to create the path for the square spring. So let's go create this, and we're going to do this one from scratch. So it's very simple actually to do this. So the square spring starts with an extrude, and I'm not going to worry about all of the dimensions. You can add whatever dimensions you want to add in here later. We'll just do, we'll go, yeah, it'll work. All right. And you start with a base. All right. Now that base does need to have fillets on it. So whether you add the fillets in the sketch or at the feature level, doesn't really matter. It's totally up to you. But you do want to have the base of the path defined in here. All right. Now once you have that, then what we need to do is create two sketches. All right, and these two sketches are going to define our surface body that we're going to need to use here in a second. So the first sketch, if you noticed, I dropped it in right at the top edge of the base. That way later when this base changes height, this path is going to move with it. All right, and then the second sketch, you need to make sure that it comes out and past the body. All right, so why do we do all that? Well, we do all that because we're going to create a surface sweep. Now, most people know how to do a regular solid sweep, and this is really no different. You've got your profile and your path, and when you first pick them, it just looks like it creates a single sheet. Well, what you want to do is go into your options and change the profile twist to specify twist value, and then how many revolutions. So now we'll say, I don't know, we'll take 10, probably 20 revolutions. I'll probably up this. Actually 10 will work. 10 will work just fine. So I now have my revolutions and I have my height. All right, so there's my height and number of revolutions. So now we've got our basic helical information. Now, why did I go through all of this? I did all of this so that I could create a 3D sketch, and in that 3D sketch, I can use what's called intersection curves. So where this surface intersects with the faces of the base, I want SolidWorks to create an intersection curve. And there you go. Let's hide the rest of this. And now I have a path. Pretty awesome. And that path I can now use with a sweep. And this is one of the new things in 2016 is we can use a circular profile along this path and then define what the diameter of the profile is. Okay, and we'll just call it, I don't know, 1/4 inch. You can play with whatever numbers you need to play with there. There we go. Okay, that, and voila, you've got yourself a square spring. And what's really awesome now is that the height of this thing, if you want to play with configurations, you now have an option to have it compressed or open. All right, very easily. Add a couple planes, cut off the top and the bottom, and flatten out the spring, and you're all good to go. So there you go. Using one surface tool just to create the intersection curves allows me to do what would have been a manual operation, would have been a lot of work. All right, so I've got a couple other examples of this. So here's one that I did probably a year or so ago, and it used the exact same technique All right, and I've got the exact same path that I created using the surface sweep and then intersection curves to generate all this. And what's really great about this particular example is that I can go into the measure command and select this arc, and I now have the length of one of these posts, the wire coil. So with just a minute or so after completing this model, I can now have, with a little bit of math, a good estimate on the amount of wiring that I'd need to finish out the coil here. So very, very good information downstream from the model. All right. And then also I created another one here. This was just kind of a goofy model I was playing around with, but turn off the perspective. And what I created here was just a loft with a handful of profiles. All right, and I can play around with these profile dimensions at any time. Created the solid. I created the solid base, and then the surface sweep around it, did the intersection curves, and then I am left with my goofy looking spring. So you can see you can use any kind of base as long as you can get those intersection curves in. Any kind of base will create any kind of spring or geometry that you're after. Okay. All right. So that's square, springs, and sweeps. Let's move on. So previously I did manual fillets. Now I want to do manual chamfers. So I've got a body here, and it's got draft along the sides. It's got a curved cut along the top, and I just can't get the chamfer that I need in the front face here. So I'm going to use a cut tool with a boundary surface, and then end up with the manual chamfer that I need in here. So how does this work? All right, so what here's the finished model, and you can see we've got draft along two of the sides and then a curved top. So it's kind of not a really complex shape, but it's got enough in it to cause me some problems. So first thing I want to do in here is I used a split tool to add this edge here so I could have this face. And this edge is going to be one of the boundaries that I'm going to use to create my boundary surface. So what we want to do is I'm going to use a 3D sketch and then a couple 2D sketches to build the skeleton of my boundary surface. Select this edge and use convert entities. Some of you may or may not know this, but when you do a convert entities, you can grab the ends of the edge and pull them off. They'll just follow along the curvature or linear geometry that you already have there. All right, so that's the beginning of it, and then I'm going to create two sketches out here. I'll pull one from there, and then we'll pierce this. So we'll get that on there, and then do the same thing over on the other side. There we go. Drop these two in. And then the fourth one is just going to be the edge that I already have down here. So let's go pull all of this together back in this boundary surface that I showed earlier. So again, boundary, I can use two profiles, okay, against two guide curves. So here's one guide curve, and you notice it pulls the entire length of the guide curve until I pick the bottom edge, and then the bottom edge becomes the limiting edge there. All right, and let's OK that. And now what I want to do is use a tool called Cut with Surface. So where by default you can find it up under the Insert, Cut, and then With Surface. I went ahead and dropped it in on my surface tool so that I've got it in my S key. So we're going to cut with surface. The arrow right here represents the direction of cut. Oh, but it doesn't work. Operation failed due to geometric condition. And this is something you'll find quite often when you're using surfacing tools. if they don't fully extend past or reach the edges of where you're trying to create face transitions, or in this case cuts, you just kind of have to possibly extend the surfaces. And that's actually one of the tricks of surfacing, is you want to almost always create your surfaces larger than you actually need, because it's easier to trim back than to add on. So I probably could have created this boundary surface a little bit bigger, but I didn't. So let's introduce another surfacing tool called Extend Surface. And what this will allow me to do is just to take the edges of my surface body and extend them on out, so we can clearly see that they extend out past the body I'm trying to chamfer. And then we'll come back in, drop in our cut with surface, make sure we're cutting in the right direction, okay that, and then hide the body, and there you go. You've got a manual chamfer. Quite easy, actually. All right, so that was a manual chamfer, and again, the technique that I used there to create the sketch base for my boundary surface, again, you can use that in lots of different scenarios. And then the cut with surface, that's a really great tool where you use a surface as a supporting or reference geometry to actually allow another feature to exist, hence the cut with surface. All right, so let's take that exact same process and take a look at a different example where we actually have to add in some countersunk holes, but the problem is the countersunk doesn't exactly reach all the way to the edge of my body, and I have to manually create in those holes. So let's go take a look at how this works. So here's the model, and let's roll back. Go ahead and section this out. So here's the finished model. Let's roll back a little bit and take a look at what I tried to do before. So back one more. And if you just go into the hole wizard and drop in a countersunk hole, we know we're going to be on a 3D sketch because we're on a non-planar face up top here. And you can see as you move your cursor around, that hole is trying to maintain tangency to the top of that face. Well, our modeling criteria is that we need the holes to be vertical. All right, so how do we get that in? Well, you could possibly drop in a plane and then have your holes. Let's press those. Oops. Have your holes in here, but let's go ahead and section this out one more time. You can see when I drop in the plane, yeah, the holes go in exactly where I told them to, but like I mentioned earlier, the countersunk doesn't actually extend out past the model geometry. So how do we get past this? Well, what we can do is actually use the existing faces that we have here and copy them. Well, we don't have a copy surface tool, but we do have an offset surface, and you can set the offset value at 0 inches or whatever unit you have. So we'll select our two faces here on both sides and offset those 0. Let's go ahead and hide our body for a second, take off our section, and so here's what I've got to start with. And just like before, I'm going to use extend surface. So we'll extend these two surfaces out a little ways. The only thing is you can't extend both out at the same time, so you have to do this twice. So we'll just do 2 quick extends, unhide our geometry, and we can quickly see that our surface body does not extend past, and our cut with surface is going to have some problems there. So what we can do is just go in and very quickly extend these on past with a couple dimensional changes. It's the beauty of SolidWorks, right? And then come in and use the same cut with surface. All right, let's make sure that we're cutting in the right direction. There you go, and there's your result. Again, cut with surface just like the extend. You can't do it on multiple bodies, so what you have to do is do it twice. And there you have it. You've now got your countersunks completing through the model geometry. All right. So that was 2 examples of cut with surface and extending surfaces to create the final geometry in a solid. So the surfaces were actually used as supporting and reference geometry. All right, this next one, if you've been through our surfacing class, you've seen this model. It's one of the I-just parts that we bring in, and we have to clean it up. So what we're going to look at here is actually removing holes. So we've got an area right in here. We want to remove this hole and create a clean face along this side over here. So how do we do that? Let's go take a look. So I've got the model in here. It's closed out. And what I want to do is we're going to just drag this in. This is actually a step file, not an I-just file. Just drag this in. And do we want to run import diagnostics? Yes, absolutely. You always run import diagnostics. Usually if you don't have a lot of faces listed out here, just let it attempt to heal all. And if SolidWorks can, it typically will heal most everything. Sometimes you may have to run it iteratively 2 or 3 times, and it'll clean itself up. I'll tell you that this face right here will not heal. This is actually one of the examples where we actually have to delete out that face, and what we end up doing in the exercise is we delete out all of these faces here and rebuild everything so that we can get a good clean area in here. But that's not what I'm going to focus in this particular example. What I want to do is remove this this feature and clean up both faces so that I can have a smooth face there. Well, to remove all this, just like before, we're going to use delete face. So we're just going to pull out all these faces, make sure you get everything inside and out, back and front. All right, and I'm just going to delete it. We do try and patch and fill. It doesn't do a good job, so we're just manually delete it. All right, and then what we're going to do is come back here and delete these holes. Well, there is no delete hole feature, but there is a tool where you select the edge and then hit delete on your keyboard. All right, so on your keyboard, hit delete, and you'll get this delete option here. And what you're wanting to do is use this delete hole. All right, and it creates this delete hole feature over here, and then you can do it a second time, or you can go back in and edit the feature. I don't know why they don't give this to you initially, but then you can come back in and select another edge, and then it will delete out, and voila, you've got a very smooth, clean face to work with. All right. Now, on this side over here, I'm not going to do this side over here because it actually will not work because of this fillet. You can see we've got a little bit of a crease hump right here, and it just doesn't work over here. This one you actually have to manually come in and rebuild everything using surfacing tools, but it's a really great exercise to do if you ever get a chance to do it. All right, so there you go, delete hole. Again, to do the delete hole, you just select the edge of the open face that you have there and hit delete on your keyboard, and it'll prompt you to delete that hole. Okay. All right, so that is removing holes from imported geometry or any geometry that you might have. Okay. And our last example here is trying to find the interior volume of a body. And this particular model, we're gonna find this volume that you see on the right in this model. Now, we've been able to do this for quite a long time without surfacing tools. I'm going to use a new tool called the intersect tool, but I am going to use a surface tool in here to help prep for it. There is a technique that has been around for a while whereby you close out all of these openings and then create a a big box around it, and then use the combine tool without merging everything to subtract, and your resulting body is the interior volume. I'm not going to go through that technique. I am, however, going to go through a different technique here where we use what's called a planar surface. So with a planar surface, I can come in and select all of these faces. You can see how I've got them selected here, and I can pick them all in one shot. Now before, I would have had to have created all these. I'm not going to go through and show them to you, but see all these boss extrudes down in the feature tree? Each one of these was an extrude to close off each face one at a time. Okay, and then at the end you create a big box around this. You don't merge results, and then you use combine to subtract and create the interior volume. Well, you can see I've got 7 or 8 features in here, and I'm going to be able to do this with 2 features. Okay, so surface plane, just roll back and just show you real quick what planar surfaces are. You just jump in here and go to planar surface, and what's nice about planar surface is you can pick edges, and these edges will come in and clean up, not clean up, but fill in all the faces. I'm not going to go through picking everything. You'll get the general idea in here. All right, and let's go back. They do have to be planar. That's the whole point of planar. But the really great thing about this is that they are they're all done in one feature, whereas below in the bottom of the feature tree here, you have to do this in multiple features. Okay, and then what you can do is jump into a tool called Intersect. All right, now this isn't actually a surface tool. It will use surfaces, but what Intersect is going to allow me to do is to select everything that I have out here, both the solid and the surfaces, and then find internal regions. Okay, hit the Intersect button, and what it'll do is it'll find my internal regions where those planar surfaces have closed off the openings in the housing. There you go. You can clearly see the volume that it found on the inside there. Okay, I believe this create internal regions is new to 2016. I don't think we had it in 2015, so don't look for that in 2015. But then what it does is it lists out all of the regions, and then if you check off, it's kind of weird, but if you check off the region here, it actually removes it from the resulting set. So what you want to do is leave that unchecked, hit OK. And you'll notice that this feature actually does take a few seconds to finish out. It is an expensive feature when you're looking at feature trees, but what I've done in one feature, again, I've had to do in multiple features down below here. And then if we hide this and then hide the external body, I now have my resulting solid here. Okay, so I've got my solid, and then what's even better, I can go into my evaluate tool, take a look at the mass properties, and now I know the volume of my interior. So I've got some useful information downstream from just the visual aspect of the interior volume. Okay, so that's using planar surfaces to support the Intersect tool to find my interior volume. Okay, so I've shown you a lot of different surfaces here: offset surface, extend surface, cut with surface, boundary surface used to replace the loft tool. By the way, the boundary tool is a solid as well, so you've got a boundary solid and a boundary surface. Surface sweeps to support those square springs, and then we just saw the planar and intersect tools, and then delete face I used several times. And all of this can be seen and learned in a lot more detail along with all of the other surfacing tools in our surfacing classes that we offer in any of our 5 locations, or we can come on site. It's a 2-day class, and it is meant for people who've never used surfacing tools. I've taught those surfacing classes for people who've never used surfacing tools and for those who have fiddled around with them, and everybody learns something from this class. So it's a really, really great 2-day class, and I really recommend anybody who wants to learn more about surfacing, you just contact any of your TPM representatives, and we'll point you in the nearest surfacing class. And when you get really, really good, you can then come in and create something like SolidWorks here. And this particular model was created by a guy named Mike J. Wilson back in 2001. And this is a complete surface body from the start to the end. I think he does do the dog tag as a solid, but everything else is done as surfaces. And when I first came across this model 10-15 years ago, I was just blown away by what he did. And again, if you go Google Mike J. Wilson SolidWorks, you can find the model. It's freely available, and you can download it and walk through it and see how he did it way back then. But everything from the machine design to goofy pictures and fun stuff, it's all available in Surfacing Tools. And so there you go. This has been our webinar on hybrid modeling with surfaces and solids. If you have any questions, please feel free to contact us, and we'll help you out with surfacing tools. Thanks a lot. Bye-bye.